In this video, we will be learning about the quotient property of exponents. So basically, we're going to learn what to do when we're dividing terms that have exponents. So again, to review from yesterday's notes, we need to know those three basic vocab words. The coefficient is always the number that's in front of the variable. The base is the where the exponent is attached to. And then we have our exponent. So again, what does x to the second power mean? That means x times x. A to the 6 means a times itself 6 times. So we're going to keep this idea in mind. Also, we talked about when a variable has no exponent specified, then the exponent is 1. So that's just a quick recap from yesterday's notes, and these ideas are going to carry over into today's notes. So for division, remember that anytime you divide a number by itself, it's always equal to 1. So like 5 divided by 5 is 1, 10 divided by 10 is 1, -3 divided by -3 is 1. So x divided by x would also equal 1. So anytime you have something divided by itself, you can just cancel it out to 1. And remember, you don't have to write ones in your final answer. So let's kind of use this idea of division to help us see what the rule for dividing is with exponents. So again, I'm going to start with example 2, and then we're going to kind of look for a shortcut. So in example 2, I have c to the 6th power. So I'm going to do c times c times c times c times c in the numerator, and then in the denominator, I have c times c. So we can cancel out any pair of, we know that c divided by c is just going to equal 1, so that would cancel out to 1. And then the next pair would cancel out to 1. So because you don't have to write the 1, we can just write what we have left, which is c to the 4th power. So again, there is a shortcut, just like yesterday, to dividing with exponents. If you notice the exponents here, we could just subtract 6 minus 2 to get c to the 4th power. So let's use this shortcut to complete example 1. So again, we're just going to subtract 9 minus 5, and we get m to the 4th power as the answer for number 1. In example 3, this time we have coefficients. So if there are coefficients involved, you do need to divide those or simplify those first. So you can use the fraction button in your calculator to do this. And so if I type in 28 over 7 using the fraction button in my graphing calculator, I end up getting 4. And then don't forget, if there's not an exponent, to put 1. So now I'm going to subtract these exponents, 8 minus 1, which is p to the 7th power. So let's kind of sum this up as a nice shortcut. So for dividing with exponents, if the bases are the same, then the first thing you're going to do is reduce the coefficients and subtract the exponents. So if we look at this next example, we're going to use these rules, and we're going to reduce 4 over 12 using the fraction button in our calculator. That reduces to 1 over 3. And then I'm going to subtract the exponents. So 19 minus 6, and anytime you have a fraction and you're subtracting the exponents, you always put the exponent in the numerator part of your fraction. So 19 minus 6 is n to the 13th power. So final answer would be 1 n to the 13th over 3. Same thing with example 5. Let's reduce 3 over 6 in our calculator to 1/2, and then subtract the exponents. 58 minus 20 is q to the 38th power. Last example, we're going to reduce 40 over 8, and that reduces to 5. And then subtract the exponents. So 18 minus 1 is z to the 17th power. Okay, let's try some more examples on the back page. Some of these are easy and some of them are a little bit more challenging. So starting with example 7, remember that if they have the same exponent, you can just cancel them out. If everything cancels out and nothing is left, then we just write 1 as our final answer. For example 8, we're going to reduce 18 over 6 to 3, and then just bring down the x. So we just get 3x. In example 9, we're going to reduce 5 over 15. Using the fraction button in our calculator, I get 1/3, and then subtract the exponents. So 11 minus 2 is n to the 9th power. So I get n to the 9th power over 3. 10 is a little bit different because I have a multiplication problem in the numerator. So first I'm going to take care of multiplication. So for multiplying, remember from yesterday, you have to add the exponents. So 2 plus 10 would be c to the 12th power, and then over c to the 5th power. Now it's a division problem, so now we need to subtract the exponents. So we get 12 minus 5 is c to the 7th power. Same thing with number 11, except this time we have the multiplication in the denominator. So we're going to start by adding those together. So we would have e to the 13th power on top, and then over e to the 12th power on the bottom. Now it's a division problem, so we're going to subtract 13 minus 12 to get just e, or you could write e to the first if you want. In number 12, because we only have one coefficient, we're just going to bring the 3 straight down and then subtract the exponents. So 18 minus 16 is r to the 2nd power. 13, we don't have to worry about coefficients, so we're just going to subtract 26 minus 14, which is r to the 12th power. For 14, you can only subtract them if they have the same base. So we're going to take a look at the x's first, and we're going to do 10 minus 7, which is x to the 3rd power. Since the y's have the same exponent, we can just cancel them out. And then we're going to subtract the z's. So 12 minus 6 is z to the 6th power. And that would be your final answer for 14. In 15, again, if they're next to each other, that's multiplication. So we have both multiplication in the numerator and the denominator. So let's combine the numerator by adding them to get s to the 18th, and then combine the denominator and add them to get s to the 11th. Then it becomes a division problem, so now we need to subtract. 18 minus 11 gives us s to the 7th power. In 16, we need to reduce 12 over 6, and we get 2, and then subtract our exponents. 9 minus 6 is e to the 3rd power. Same thing in 17, reduce 2 over 4. Using the fraction button in your calculator, you should get 1/2, and then subtract the exponents. So 8 minus 2 is L to the 6th, and just make sure you always put it in the numerator when you're subtracting. 18, first I'm going to check, can I reduce 3 over 5? And I actually cannot, so I'm going to keep it as 3 over 5, and then subtract my exponents. So 13 minus 8 is e to the 5th power, and always put it in the numerator when you're subtracting. All right, last row. For number 19, again, you only have one coefficient and it's in the denominator. So just keep 3 in the denominator. Then you're going to subtract the x's. So I'm going to do 5 minus 1 to get x to the 4th. Remember, it always goes in the numerator. And then subtract the y's. 8 minus 2 is y to the 6th. Final answer. Same thing with number 20. There's only one coefficient, so we're just going to keep 4 in the denominator. The p's have the same exponent, so they get to cancel out. And then we're going to subtract the q's. 20 minus 15 gives us q to the 5th. And then subtract the r's. 2 minus 1 is r to the 1st, or you can just write r. So final answer, q to the 5th, r over 4. In number 21, we're going to reduce negative 6 over 18 using the fraction button in our calculator. I get negative 1/3. The x's have the same exponent, so they cancel out. And then I just need to subtract the y's. So 7 minus 2 gives me y to the 5th, and I would put that in the numerator. Last one, number 22, I have multiplication. So I'm going to take care of multiplication first. So with multiplying, remember you add the exponents. So 8 plus 5 is m to the 13th power. And then in the denominator, 3 plus 1 is m to the 3rd power. Now it's a division problem, so you're going to subtract exponents. 13 minus 3 equals m to the 10th power. All right, so now hopefully you have a better understanding of what to do with exponents when you're dividing. Feel free to reach out to your teacher with any additional questions.